module is going to elaborate on the technical classification of cyber attacks. Previously we saw what is a cyber attack and what are the different characteristics, etc. Here in this section, we are going to discuss on the most common types of cyber attacks. Some of the common cyber attacks are DOS and DDoS, that is denial of service and distributed denial of service attacks. XXS attack, that is cross-site scripting attack. SQL Injection Attack, Structured Query Language Injection Attack. Man-in-the-middle attack, birthday attack, password attack, eavesdropping attack, phishing and spear phishing, drive-by attack, and finally the malware attack. We are going to see elaborately one after the other. Actually, this attack will make the system not to respond to the actual service requests by overpowering the system resources. For example, occupying the bandwidth. Okay. Distributed denial of service attack is also similar to DOS attack, but here the major difference is that the attack is launched from series of host machines. The denial of service attacks, they do not actually provide any direct benefit for the attacker, unlike all the attacks which we have discussed previously, unless the attacker is a competitor who might benefit as a result of the attack. These kinds of attacks are also made with the purpose of taking the system offline so that a different attack can also be carried out at the same point of time. As I discussed, DOS and DDoS are not single attacks. There are most common types of DDoS and DOS attacks available as well. They are the sink flood attack, TCP sink flood attack, teardrop attack, Smurf attack, ping of death attack, and botnets. We'll also discuss about them one after the other. Sink flood attack. The sink flood attack comprises the initial handshake process, which is common in communication, and makes the server unavailable for the actual traffic. So, it sends the sink packets, also known as the initial connection request establishment command. This is sent repeatedly and eventually overwhelming the targeted server. This attack generally results in a very slow or sluggish response, or sometimes even no response for the legitimate requests. The second one is TCP sink flood attack. A buffer space is usually created during the TCP session establishment, that is the Transmission Control Protocol session establishment. When the connection happens, this attack fills up the target machine with multiple requests for connection. So it also makes the target machine to time out because they are time to live commands. So the target machine time is out when the machine is waiting for permission to connect from the server. There are certain countermeasures to a TCP sink flood attack. They are reducing the time on open connections when they are not used. Second, firewalls can be installed for suspicious traffic, rather to monitor and prevent suspicious traffic. Third one, connection queue size can be increased. The third one is a teardrop attack. Once again, teardrop is a DOS attack where the fragmented packets are sent to the target machine. As the machine cannot reassemble the packets on the other side due to the error in TCP/IP fragmentation reassembly, These actions make the victim's computer to crash as it is overwhelmed with packets. Next one is the Smurf attack. Smurf attack is also a DDoS attack which involves IP spoofing, that is Internet Protocol spoofing. Generally, a ping is issued to the entire IP broadcast addresses that stimulates the response from every computer to ping packet onto the target computer. This process can be repeated and automated to generate a large amount of network congestion. Therefore, the IP directed broadcast at the routers should be disabled in order to protect the devices that are connected to the local area network or the wide area network. This prevents the Internet Control Message Protocol echo requests at the node level on the LAN or a WAN. Ping of death attack. The ping of death attack happens when the network packets are used to ping the target machine with the size of packets which are larger than the maximum size, that is 65,535 byte size. That's a standard size, all of us know. Since this type of or this size of data is not allowed, the attacker fragments the data. So the victim's system crashes due to the load of data causing an overflow. These types of attacks can be avoided by installing a firewall which ensures that the maximum size data are blocked. Once again, as I told you, we are going to discuss about firewalls at the later point of our sessions. Botnets. Botnets are millions of computers which are compromised with viruses by the hacker, taking control over and carry out DDoS attacks. The bots are generally used to attack the victims, often sending or flooding the victim's server or computer with data to overwhelm the processes. As these bots can be located anywhere, they are generally very difficult to identify. Following steps are used generally to mitigate botnets. First of all, the RFC 3704, that is a request for command draft number 3704. It discusses about how the spoofed addresses can be identified by comparing the incoming traffic's address with the database which is already created and the data are blocked for any such source. Second one, black hole filtering. So this drops packets from the suspected node's traffic. When the attack is identified to interface the next hop, the host will broadcast the updates from the router to route all the network traffic to the victim's server. Using a third-party web resources, XSS attacks will run a script on the victim's browser. Actually, it is a browser-based attack. The application exactly injects a load with a malicious JavaScript into the website database. The malicious script is executed in the user's browser in the HTML form where the user requests the page from the website. For example, user cookies. They are sent to the hacker's server, which is later on can be extracted and used to control the entire session. The risky part of that is it will lead to enable the hacker to access and steal the cookies, then log keystrokes, and then capture screenshots and explore and collect the entire network information. Sometimes they can even take control or access remotely the user machine. JavaScript is maintained widely on the web contents. So XSS can easily take advantage over VBScript, ActiveX and Flash. Users should be given access to disable client-side scripts. they can change the special characters like greater than, less than, ampersand, question mark, slash, etc. to their respective URL encoded or HTML equivalents. Developers can clean the user data by validating, filtering, and escaping before it is reflecting back to the user, which effectively protects the user against these types of XXS attacks. In database-driven websites, one of the most common issues found is this SQL injection attack. It happens when the SQL query is executed with the help of the database, which is the input from the client and the server. To run predefined structured query language commands, instead of login and password, the commands are placed in the data plane. So SQLIA reads sensitive data and modify the data by injecting irrelevant data. So administration operations could be executed such as updating the data field, deleting the data tables from the databases, shut down the database, and in some cases issuing unwanted commands to the operating system. A particular form in the site may also ask for user's account name, and it may also send to the database the user account number to get that associated information. I can just quote an example. The dynamic query generally may look like select star from users table where account number equal to within quotes plus user account number plus etc. You can see this how the queries look like. When this query is executed for user who properly enters the account number, it gives option for attackers. For example, when the account number is given like quotes or 1 equal to 1 quotes, it just gives the below query of select star from users table where account number is equal to quote or 1 etc. So the above where query evaluates to true and returns the information for all the users instead of one user, because it's not particularly asking for one user. It's a generalized command. SQL injections mostly work if a website uses dynamic SQL. Due to the frequency of earlier functional interfaces, the SQL injection is obviously seen with PHP and ASP applications. SQL injections have been less likely to get exploited by J2EE and ASP.NET applications because their interfaces nature are different. Sometimes even following methods can be followed. They are allow least privilege model of permissions in the database. Allow only clearly parameterized queries such as well-prepared statements. Third, you can rely on certain stored procedures. These are all the safety measures and these can protect from SQLI. The queries and codes used in the database should be strong enough to prevent against this SQL injection attack. In addition, the input data can be validated at application level itself with a whitelist.